All right, DI 62-3 says solve the polynomial inequality. So I have 4x cubed is greater than or equal to 3x plus 1. So when we're trying to solve polynomial inequalities, I need to find all of the zeros. And then we put those zeros on the number line, and then I test the regions that are going to be true or false. So then I'm going to subtract the 3x and I'm going to subtract the 1. So I'm going to get 4x cubed minus 3x minus 1 is greater than or equal to 0. Now I need to do my p's over q's. So you get 1 over 1, 2, and 4. So that gives me plus or minus 1, plus or minus 2, and plus or minus 1 over 2 and 1 over 4. So I need to go through and I need to test them. So maybe let's try positive 1. For I don't have a square, negative 3 and negative 1. Bring down the 4, multiply, add, multiply, add, multiply, add. So it worked. So I know that positive 1 is going to be a solution. Now I'm going to be left with 4x squared plus 4x plus 1. And so I need to think about how that's going to factor. To see, let's do this factor into 2x plus 1. 2x plus 1. 2x is 4. 1, good. 4x squared, yep, so that works. So, and then this 0 here, I get x minus 1. So it's always x minus your 0. So my zeros are going to be positive 1 and negative 1/2. So now I put that on a number line, negative 1/2 and positive 1. Because it was equal to, that's why these are going to be solid circle. And now I need to test each of these regions. So like test negative 2. Well, if I plug in negative 2, I get a negative. If I plug in negative 2, I get a negative. If I plug in negative 2, I get a negative. So a negative times a negative times a negative is a negative. Then if I plug in 0, so a value right here like 0, then I get a negative times a negative, a negative times a positive times a positive. So this is also negative. And then if I plug in a value like 2 or 3 or 4, positive, 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 so that's going to be a positive. And so it's looking for all the values that are greater than or equal to 0. So those are all of my positive values. So that's going to be my answer there. So it's going to be from 1 to positive infinity. Now I'm going to briefly talk about number 3. With number 3, it says x cubed plus 2x squared all over 2 is less than x plus 2. So to get that 2 out of the denominator, multiply everything by 2. And so you're going to get x cubed plus 2x squared is less than 2x plus 4. Then bring everything to one side. And now that's compared to 0, now you do your p's over q's. And then you do the same thing like number 1. You put them all on your zeros on a number line, etc. On number 4, these polynomials are not equal to 0. So we have to spend time doing that. So this 9x cubed equals 5x squared plus x, well, I have to bring everything to one side. Now I can't do p's over q's, and the reason is because your p has to be factors of your constant. I don't have a constant. Well, this implies that there is a value for x that's in common with everything, so I need to factor that out. Now if you want, you can do your p's over q's, but it's quadratic, so you can also use quadratic means to factor. So it says use the given information about theta to find the exact values. So remember, sine of 2 theta is 2 sine theta cosine theta. It says cosine theta is between 0 and pi halves. So we draw our triangle between 0 and pi halves. And cosine is adjacent over hypotenuse. So I have to use the Pythagorean theorem to find that missing value there, find what my sine theta and cosine theta is, and I replace them with sine theta and cosine theta and simplify. You do the same thing with cosine of 2 theta and tangent 2 theta. You have to look up the identities. On number 8, it says find the degree. The degree is the highest power, so 5. The leading term, it's the term that actually has that highest exponent, so 3x to the 5th. The leading coefficient, that's going to be the 3. The constant term, that's going to be 1. And the end behavior, because it's odd and positive, it's going to look like that. It says find the point slope, slope intercept, and standard form of the equation. So I'm just going to talk about it, but set us up. Remember, we always start with the point slope. The point slope is y minus y1 equals m times x minus x1. That's the point slope form. So we plug in our point and we plug in our slope. So we have y minus y1 equals our m times x minus x1. Now I simplify this. So that right there, that's our point slope. Now you get y by itself, that's your slope intercept. You get x and y on the same side, then it's in standard form. But remember, standard form, they all have to be integers, so if you have any fractions, you have to multiply to get rid of the fraction, and then your x part has to be positive.